Alright, so welcome to a new video. Today we're running this problem, binary tree maximum path sum, hard problem LeetCode. I have solved this already, but I'm pretty sure I solved it like a year ago. Oh, wait, 1, 2, 7 months ago. I can't count. Anyways, so I solved it 7 months ago. I'm pretty sure I watched the video, but I'm pretty sure now I can solve it without watching a video. So yeah, we'll just kind of just do it raw. Like that one Gordon Ramsay guy. So let's just go ahead and read the problem. So a path is in a binary tree. It's a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting to them. That's a very strange way to say a path. Just say like they're connecting. Anyways, this makes sense technically. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. Okay, so that's a lot of notes. We haven't even gotten to the input. The path sum of a path is the sum of the nodes value in the path. Okay. Given the root of a binary tree, we got the input, return the maximum path of any non-empty path. Okay. So let's start out with the input and the output. We know for our input, oh, the song's pretty good. We know for our input, I need to add this song. All right, and then so for the input, we know that our input is just root of bt, and our output is supposed to be an integer, and it's supposed to be the max sum of a path of an input. And then to note, anyways, so they say that a path is basically sequence of nodes with edges connecting them. And then also say that the path node can only a single node can only appear once. So those are two things. And then another third thing is that path doesn't need to pass through root. Cool. It's very cool. So now that we know that, oh, this is pretty loud actually. So now that we know those three, I can go through like an example to like kind of showcase like all three of these in the same example. But let's just say that let's take note of another definition, which is a path sum. Basically, all vowels of nodes in one sum. Okay, pretty much it. So we took some notes, input and output. So let's ask some questions. So one question is, what is the min val of node.val? And then another question is, what is the min size of binary tree? So if this was an interview, I'd ask the interviewer. He'll probably say something. But I guess we can tell from this example too that I'm gonna guess let's just scroll down. Yeah, so it's not negative infinity. So the min value is actually negative 1000. And then the min size of it is 1. Okay, so that's a good thing to note, I guess. So we'll always have like a value for the min size and for the max for the path sum. It won't be just null, right? All right, so yeah, we asked some questions, took some notes of the input and outputs. Let's go over some examples. And I want to go through some examples that kind of showcase this. And I feel like this example is pretty good for it. So I'm just going to copy it in a Jamboard. So negative 10, 920. 20 and then 15, 7. Yeah. Right, so they point like this. Pretty cool. And now we want to find the max path sum. Obviously here, what we're going to do initially is just go to the root. And we can tell that we will not get a max path sum just by looking at it. Mostly because we're at -10. So that makes sense, right? But if you look at it in a certain direction, when we actually go for a max path, here's what we're actually like looking for. We're looking for this. Looking for this. When we go right, we go left. Or we're looking for this. When we go right, we go right. Right? But we can't do this. We can't do boom, 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 then go back up and then boom. We can't do that. Also, that'd be kind of cool. We can't do that because it states where is it? It states that the path, no, it states that a single node can only appear once. So we can't have both. We can't have both. We can, from this 20, we can only go here or here. So that's something interesting. But I feel like it wouldn't really matter because what I'm thinking about right now is that the max path we'll have, or that we'll get. So for example, right? Let's say we already found the max path to the left, right? Which is just 9. At every node, we want to get the max path of every node in its subtree. So once we're at this 20, we're like, okay, what is the max path, right? What is the max path? It's either 15 or 7, right? 15 or 7, right? We'll obviously go for the 15. So that's going to be our path, right? Because for this problem, it's a binary tree problem. So we want to treat every subtree as its own problem, right? So when we go for 10, what is the max path of 10? You go 9 or 20. Well, we go 20, right? And then so on. So that's kind of it. But it doesn't have to start from the root, right? The path doesn't have to start from the root, so it can be at this 20. Okay, it can be at this 20. So I'm pretty sure if we do get the max path, it'll just be 15 and 7, right? Because we start at the 20. 20 gets its left and right, which is 15 and 7. And those are the max paths of their own subtree, because they don't have any children, technically. So it is the max path in their own subtree. So it'll be 15, 20, and 7. If you kind of want to look at this, I remember there's like one problem that I did called diameter of a binary tree. I'm pretty sure it's the same thing, where we go to get the max diameter of the tree. We just went all the way. We didn't have to start the root. We would have to go to the depth. We went to the depth and then went around like this, right? We didn't go like this. We didn't go like this. We went like this, like a singular path that goes in one direction. Yeah, it goes in one direction technically, but if you look at it like this, I guess like both directions, but still whatever, right? So yeah, so that's kind of what I'm going to go for. Just note, reminder, diameter of binary tree, go depth, then compare. Go depth, compare at middle or at cur. Go depth right, depth left. And so that's what I'm kind of getting reminded of, on how to solve this problem, because we're only going in one direction as well, right? So yeah, that's pretty much it. So yeah, let's go through some kind of matching what we can do. Well, we kind of already matched with the diameter of a binary tree problem. But let's go ahead and kind of figure out what we want to do. So what do I want to do? Well, first off, we can solve this with a global variable. So like max path or result is equal to max of a max basically. And then we're gonna do depth first search, of course. And then we can either do it without global variable or with global variable. Without global variable, so we can do like node and then max path or stuff like that. I don't know. And then just return that to just like keep returning that, I guess. I don't know. Or we can just go like this, and then that's basically it. And then just compare. I'm pretty sure we can do that too. And then we're also going to use the max function, and we're going to go left and right with that. I think we're going to do in order. In order traversal, we go all the way left, and then current, and then right. I think. That makes sense. Oh no, I'm not sure yet, actually. Let's see when we code. So, we matched. Now we got a plan. So I'm obviously not sure how I'm gonna plan this out. But I'm gonna go through with the global variable root. So let's say res is equal to 0, and then we have DFS. DFS takes a node. Then what do I want to do? Well, of course the base case. So if not node, since we're kind of wanting to get the max path, so if null, then just return 0. And then what I want to do is I want to go all the way left. Right, I want to go all the way left. So go left, and then go right, and then let's see. What do I want to do? So go left and right. Obviously, I want to get the max path from the left and right. So I'm gonna say left is equal to left sum is equal to left. We go left, and right sum is equal to the right. So I know we're going to return sum, the current path sum. So current path sum. Okay, so but let's say we start from here, right? We're at this 20 and 15 and 7. So So just going back at here, I know what do I know? I know if I go from this 10, I know it has to be like this. Right? So let me think. So I think it makes sense when I call left. Ooh, okay. So okay, I figured it out. So when I return, let's say if I want to return to this 20, return to this 10, I have to return the max path, right? Of either 15 or 7. Right? Does that make sense? So I want to return. So I guess I can say current path sum is equal to no.val equal to the max of left sum or right sum. Wait, can I do this? Plus, can I do that? I think I can, right? Plus no.val. Right? Does that make sense? Because, yes, because I want this -10. Let's just say I want to return to -10. Right? So -10, I can't do this. I can't go like this. I have to go like either like this or like this. And that's what I'm doing here in this case. So in the case returning, find path that is max of left or right. And then we're also going to have another case because we know that 15 and 7 are the max paths in this example. So there's one thing that we want to do. So I guess this is actually like post order. We get the left and right, and then we kind of compare with the current. So we can say that the res is equal to max of res or left sum plus right sum plus no.val. Right? So I think this works because let me think. I think this code works. So in the case that max path sum is the root and this will make sense, right? Because in this case current path sum will be the max. So when we call 20, right? When 20 is called, it calls left and right. And then when we call 15, because it calls left, it will return 0 back. So 0, 0, and then right sum is equal to 0. And then in this case, it's its own path. So it's going to return 15. No, it's going to go through here first. But I don't think this will matter. But then the current path sum, it will return it will return 15 plus 0. So yeah. And then 20 will get 15. Right? And then it has to call right, which is 7. 7 gets 0, 0 for left and right because of this. And it's going to return 7. So now, once we have left and right sum, we're going to check in the case that the max path starts at the root, right, of the current subtree, not the other subtree. So then we say res is equal to the max of res, the current res, or left plus right plus no.val. And then yeah. But then 20 in this case, even though we have the max path sum already, because we know that 15, 20, and 7 are the max path sum, it's still going to return the max of its left or right plus its value. So it's going to return this either way. And then 10 is going to compare to this, which is just this. Current path sum, no, which is just this. It's going to get this. And then yeah. So that's basically it. So yeah. In this case, res doesn't equal to the max. It's not more than the max, which is because this is 9, 9, 1, 21, and then what, 36? But this is like 35 plus 7, that's like 42. No, wait. Yeah, 42. Okay, cool. It's left 42. All right, so yeah, it's kind of it, basically. We kind of ran through the pseudocode a little bit. Kind of made it make sense. So this makes sense, but in the end, our plan, we have to call the FS with the root. And then, oh yeah, we have to reference this as non-local, res, so non-local. And then we have to just return res. So yeah, yeah, so let's just go ahead and kind of code this in LeetCode. Let's put it in as a plan first and just kind of just follow it. Oops. All right, so first thing we want to do is initialize our global variable. So we say that res is equal to 0. Let's create our function to solve this problem, which is dfs. Takes in node. And then first off, we got to make our base case. So if not node, then just return 0 because we're going to add up anyways. And then we got to reference non-local res. And now we are going to do recursion on the left and right part of the subtree. So left sum is equal to, we know, because we know, we say left sum because we know that we're going to return the max path of the path that we're at right now. So left sum is equal to dfs, know that left, and right sum, right. And then we have two cases. So we have the case where max path, max of the path sum is at the root. Is the root, and we have the case where we return max path to return up to root, right? So let's go ahead and code this part. We already have it coded. So res is equal to the max of either the current res or starting from the root, where we get the left and right and we add it with the current. So left sum plus right sum plus know that val. Right, so and then we have to code the case where we return the max path up to the root. So current path sum is equal to the max of either left sum or right sum plus know that val. And remember, we say left sum or right sum because we can't do this. We have to do this or this, right? So that's why we say the max if we are left and right. And this problem, we want to get the max path, so we're obviously going to get the max of either, right? Of either or. And then once we have that, res should hold the max path once we're done with recursion, or the max path sum once we're done with recursion. And then, oops, typo. So we're going to return the current path sum, and that's how we're going to get left and right sum, right? And then, yeah, we're just going to, once we're done with recursion, we're going to call dfs root to start our recursion, then return res once we're done with recursion. So this should run. Accepted. Submit. Wrong answer. -3, output 0. Oh yeah, oops, I forgot. We stated that the min size of the min value of the node.val is -1000. So I guess we can say that we can start our result at -1000. So, or -1001. So, submit. Wrong answer still? Whoa, that's crazy. Wait, really? Hold up. So, it's 2 and 1. Whoa, that's crazy. That's so crazy. That's actually so crazy. So, so I know that. So this is what they have. So this is what they have. They have 2, and then -1 is the left, I think, or whatever. It's basically saying that 2 is its own path. I mean, that's true. Well, it could be its own path. Well, that's true. Only thing is, how do I code this? I can't really say that the res is equal to no.val or root.val. I can't say that, right? I'm kind of confused. Now I'm wondering if I coded this right. Well, I mean, I guess I'll just try it out. I don't know. So root.val. I don't know. Yeah. Hmm. Oh, there's one interesting thing. Okay, so this is what they're doing as well. So this is what they're doing. Wait, this is kind of weird. Wait, this is kind of weird actually. Um, Wait, this is so weird. I don't know. I mean, that makes sense. Wait, that makes total sense though. So they're doing this. That makes total sense. Okay, yeah, this makes total sense. Okay, okay, okay. Okay, I get it. I get it now. So let me just explain before I code it up. So, you know in here, how I say res is equal to the max of left plus right plus no.val? Um, that is true. But, so, but they're thinking really smart. They're like, okay, well, there's a negative here, so we don't really care about that because that will only decrease our max path sum. So what we're going to do, if it's negative, just don't count that. Just do this, right? Just do this. So that's why they get 4 instead of 3. So the way that they do that, let me put res back to -1001. So the way that they do that is that they say left sum is equal to whatever this is, and then I can say if Wait, I forgot how to do like I forgot how to do it. So how do you compound if statements? Compound if statements, Python. If, yeah, if more than equal to 0, else 0. I'm pretty sure I can do this, right? Can I do that? One line if statement Python. Oh no, I'm wrong. I can't really say like I guess I can do this, right? I think that makes more sense. Right, and then this will work. Okay, cool. Yeah, okay. That makes total sense. Yeah, because they're not counting the negative. Because if they see a negative, then just count it as 0. Like, who cares, right? Yeah, that makes sense. So yeah, so there you go. That's how you solve the problem. For time complexity, it's O of n because we go through every node once in the binary tree. We don't go backwards at all. For, let's say time. Okay, for time, it's O of n. Yeah, so we iterate through every node once. For space, it's O of 1 extra space. We're only using constant variables to save our solution. So yeah.